Hello everyone, welcome to my channel. In this video we are going to discuss about properties of integer like closure property, commutative property, associative property, distributive property, identity and inverse. We'll apply all these properties to all operations like addition, multiplication, subtraction and division. Now let's discuss about closure property of integer for additions. It says that if a and b, two numbers, they are integers, then their sum a plus b will also be an integer. So let's take one example. A is equal to 4 and b is equal to -5. Then a plus b is equal to 4 minus 5. We have to subtract from 4 from 5, will get 1, and which sign will come? Minus sign. So we can take one more example. Equal to 6 and b equal to 5. Then a plus b is equal to 6 plus 5, which is equal to 11. This is an integer. This minus 1 is also an integer. So we can say that integers are closed under addition. We'll do this property for multiplication. Let's take two numbers a and b, two integers. Then their multiplication is also an integer. ab will also be an integer. Let's take a equal to 2 and b is equal to 3. Then a into b is equal to 2 into 3, which is equal to 6, and 6 is an integer. Similarly, I take a to -1 and b equal to 2. Then a multiplied by b is equal to -1 into 2, which is equal to -2. So this is also an integer. So we can say that integers are closed under multiplication. Here also yes will come. Let's do this property for subtraction. It says that if a and b are two integers, then a minus b will also be an integer. So let's take one example. A is equal to 2 and b is equal to 1. Then a minus b is equal to 2 minus 1, which is equal to 1. This is an integer. Similarly, I'll take 2a equal to -3 and b is equal to -4. Then a minus b is equal to -3 minus -4. Now subtract 3 from 4, will get 1, and which sign will come? Plus sign, only because 4 is greater than 3. So this is also an integer. So we can say that integers are closed under subtraction. So we can write here yes, they are closed under subtraction. Yes. Next we have division. Same, we will take two integers a and b. These are integers. So we have to prove that a upon b also an integer. We know if a is equal to 2 and b is equal to 3, then a upon b is equal to 2 by 3. This is not an integer. We can say that integers are not closed under division. So we can write here no, they are not closed under division. Next we have commutative property of integers. First we'll do it for additions. It says that when we add two numbers a and b, and these are integers, when we add these two numbers a and b in any order, we get same result. It means that a plus b is always equal to b plus a. So let's take a 3 and b 2. Then let's prove this thing. A plus b is equal to 3 plus 2, which is equal to 5, and b plus a is equal to 2 plus 3, which is also equal to 5. It means a plus b means a plus b is equal to b plus a. Let's take one more example. Let's take a -3 and b 2. Then a plus b is equal to -3 plus 2, which is equal to 1, and what sign will come? Negative sign will come. So and b plus a is equal to 2 plus negative 3, which is equal to 2 minus 3, which is also equal to minus 1. So it means integers are commutative under addition. So we can say that they are commutative under addition. Yes. Now let's do this commutative property for multiplication. It says that when we multiply two numbers a and b in any order, we get same result. Means a, whether we multiply a into b or b multiply by a, we'll get same result. So let's prove this property. A, I'll take negative 3 and b, I'll take negative 3. So a multiplied by b is equal to negative 3 multiplied by negative 3, which is equal to, which sign will come here? This is negative, this is negative. So even number of negative numbers we have. So it means we'll get result in positive. So it will become 3 into 3, which is equal to 9, which is also an integer. Similarly, I'll take one more example. A minus 5 and b 4. Then a multiplied by b is equal to negative 5 into 4, which is equal to negative 20. And I multiply like this now. B first and then a. It will become 4 multiplied by negative 5, which is equal to negative 20. Same result I got. It means integers are commutative under multiplication. So here we can write yes, they are commutative under multiplication. Next, let's do this property for subtraction. It says when we subtract two numbers in any order, we'll get same result. Let's see this property is correct or not. So according to this property, a minus b should be equal to b minus a. Let's see whether this is true or not. So let's take a negative 3 and b 5. Then a minus b is equal to negative 3 minus 5, which is equal to minus 8. And let's see b minus a. B is 5 minus negative 3. Correct? So 5, what sign will come here? Plus, and we'll get 3, which is equal to 8. This is negative 8 and this is positive 8. So it means this property is not correct. So a minus b is not equal to b minus a. So we can say that integers are not commutative under subtraction. So we'll write here no. They are not commutative under subtraction. Now let's do this property for division. According to this property, if a and b are two integers, then a divided by b equal to b divided by a. Is this correct or not? Let's see this. Let's take a 3 and b 2. Then a upon b is equal to 3 by 2 and b upon a is equal to 2 divided by 3. We know this 3 by 2 is not equal to 2 by 3. So we can say that this property is incorrect. So we can say that integers are not commutative under division. So we'll write here no. Now we have associative property. Let's apply this property for addition. To prove this property, we need more than 2 integers. So I'll take 3 integers. If we change the grouping of numbers, it won't affect our result. Means first we'll do it for addition. If I take 3 integers a, b and c, then a plus b plus c. First I'll take this group of numbers is always equal to a plus b plus c, and this side I'll take this group. Means here first I will add b and c and after that I'll add a. But in right hand side first I will add a and b and after that I will add c. So let's take one example for this. A 3, b 2 and c negative 1. So first I will take left hand side. Left hand side is a plus b plus c. So a is 3, B is 2 and C is negative 1, so it will become 2 minus 1. 3 plus this will become 1, so I'll get 4 answer. So now let's take right hand side. Right hand side is A plus B plus C. A plus B plus C, which is equal to A is 3, B is 2 and C is negative 1. It will become minus 1. This is 5 minus 1, which is equal to 4. So this equal to left hand side is equal to right hand side. So we can say that integers are associative under addition. So we can write here, yes, they are associative under addition. Now let's do this property for multiplication. It says that if A, B and C are 3 numbers, then A multiplied by B multiplied by C. First I'll take this group is always equal to A multiplied by B. Now I'll take this group multiplied by C. So let's take one example. A, let's prove this property. 2 and this is equal to negative 1. So I'll take left hand side, which is equal to A into B into C. So A is equal to 3 multiplied by B is 2 and C is negative 1. So I'll get, first I have to multiply B with C. So I'll get what? I'll get negative 2, correct? And then I have to multiply this 3 with 2. I'll get negative 6. So let's take right hand side, and our right hand side is A multiplied by B. First we have to multiply this and then after that we'll multiply with C. So A is 3, B is 2 multiply by negative 1. This is equal to 6 multiplied by negative 1. So what result will come? Negative 6. This and this are equal to, means left hand side is equal to right hand side. So we can say that integers are associative under multiplication. So we can write here, yes, they are associative under multiplication. Next, let's do this property for subtraction. So similarly, we'll take 3 numbers. So we have to prove that A minus B minus C is equal to A minus B minus C. Let's see whether this property is correct or not for this subtraction. Let's take A, 3, B, 2 and C is equal to negative 1. So left hand side is equal to A minus B minus C. A is 3 minus B is 2 and C is minus and negative 1. I'll get 3 minus 2 plus sign will come here. This will become 3 minus 3, which is equal to 0. Now let's see whether right hand side is 0 or not. Right hand side is equal to A minus B minus C. First we have to subtract this B from A. This is 3 minus 2 and minus C. This is negative 1. This will become 3 minus 2 will become 1 and this will become plus 1. So I'll get 2. So here see, this left hand side is not equal to right hand side. So we can say that integers are not associative under subtraction. So we can write here no. Now let's do this associative property for division. It says that when A divided by B divided by C, first I'll take this group and is equal to A divided by B divided by C, and right hand side I'll take this group. Then we'll find if I'll take 3 numbers A, 3, B, 2 and C is equal to any number, you can take 4. Then we'll find, if we put all the values, we'll find that left hand side is not equal to right hand side. So we can say that integers are not associative under division, and we'll write here no. Now let's discuss about the distributive property of multiplication over addition. So according to this property, the sum of 2 numbers multiplied by third number is always equal to the sum of the product of each number with the third number. Means if we have 3 numbers A, B and C, then the sum of these 2 numbers B, plus C multiplied by A is always equal to the multiplication of A with B plus the multiplication of A with C. This means we are distributing multiplication over addition. Let's take one example. For example, I'll take A1, B2 and C4. Then left hand side is equal to A into B plus C, which is equal to A is 1 into B is 2 plus C is 4. So it will become 1 multiplied by 6, which is equal to 6. Now take right hand side. A multiplied by B plus A multiplied by C, which is equal to A is 1 into 2 plus A is 1 into 4, which is equal to 2 plus 4, which is equal to 6. We can say that the multiplication of integers is distributed over addition. So next we'll take this multiplication over subtraction. Similarly, here we'll take three numbers A, B and C. Then A multiplied by the subtraction of these two numbers B minus C is equal to A, B minus A, C. Let's prove this. I'll take A is equal to 1, B 2 and C 4. So left hand side is equal to A into B is 2 minus 4, which is equal to A multiplied by this number will come minus 2, and when we multiply minus 2 with 1, I'll get minus 2. So let's take right hand side, which is equal to AB minus AC. A is 1, B is 2, minus A is 1 and C is 4. It will become 2 minus 4, which is also equal to minus 2. So left hand side is equal to right hand side. We can say that multiplication of integers is distributed over subtraction. 0 is the additive identity for an integer. Why? Whenever we add 0 to given integer, we'll get same number. Its identity won't change. For example, if I take A equal to 4, then if I add A plus 0, I will get 4 plus 0, which is equal to 4, the number itself. So we can write this as A plus 0 is equal to 0 plus A, which is equal to A. Next we have additive inverse. Additive inverse is the opposite of a number, because whenever we add the opposite of the number to a given number, will get additive identity, means 0. For example, I have a integer x, and the additive inverse for this x will be minus x, because when I add these two numbers, I will get 0, the additive identity. So the negative of a number is always its additive inverse. We have multiplicative identity, and 1 is the multiplicative identity for all integers. Why? Because whenever we multiply any integer, suppose x with 1, we'll get same number. So 1 is the multiplicative identity for all integers. These properties are very helpful while doing calculations. They make our calculations very easy. In next coming video, we'll do examples related to these properties, and we'll see how these properties are helping us in calculation. Thank you everyone for watching my video.